All right, so 2.3 is called polynomial and rational functions. It's actually a pretty big section. We're going to chunk it up. So the first part, which is what we're going to do today, is stuff that you should have already seen in Algebra 2. That's the good news. It is polynomial long division and synthetic division. So we're going to go through those things, a little bit of application on that, and then after your test, which is Thursday, we'll finish. So on Friday, we'll finish this section, and that will get grouped in with the next amount of content for the next assessment. So we start with long division, which is exactly as it sounds. It's long, okay? It is long division with dealing with, just like you would have done numbers, right? If I divided like 2 into 331, that's long division. But obviously now we're dealing with polynomials, so a mix of coefficients and variables. So the first step is to arrange the terms of both the dividend and the divisor in descending powers of the variable. So both what you are dividing into and what you're dividing by has to be arranged in order of highest exponent down to none. Then you start by dividing the first term of the one on the outside into the first term underneath. So divisors, what's on the outside, dividends, what's underneath, okay, for vocab terms. So you're going to start with first and first. Divide outside number into the first term, and then put that number at the top, multiply every term on the divisor, the thing on the outside, by whatever's at the top. And then this says to subtract, and I actually choose to change the signs and add, because I've been doing this a long time, right? The grays. I've been doing this a long time, and the biggest mistakes people make, silliest mistakes, are when it comes to subtracting negatives, right? We tend to forget about the negatives. We tend to flip the signs and then get the rest wrong. So to avoid this, we do change the signs and add. It's the same thing. If you prefer to subtract, continue to subtract. That's fine. Just don't forget. Then you bring down the next term just like you normally would in regular long division, and then repeat that process until the exponent at the top is larger than the exponent on the outside, okay? So you stop, and it says it'll occur when the degree of the remainder is less than the degree of the divisor. So if the exponent on the outside, the exponent underneath is less than the one on the outside, we're not dealing with negative exponents here, that's when we stop, okay? You sometimes have a remainder. Your answer in that case, you will write your answer as the quotient, which is the thing at the top, plus the remainder over the divisor, which is what's on the outside. So dividend underneath, divisor outside, okay? Or dividend goes over divisor if you see it in fraction form. So when you write these answers, you will see them written like that. Quotient plus or minus sometimes, divisor over, or remainder over divisor. So that's just the format of your answer. All right, first question. So we're going to walk our way through this kind of slow and steady. If I go too fast, you need to just let me know. The first thing I need to do is look at what I'm dividing into and by, and make sure that it is in order from highest exponent down to none, and also that there's no terms missing. Whatever the highest exponent is, if the highest exponent is to the third, then I need a x to the third, an x to the second, an x to the first, and a no x. If I am missing any of those terms, I fill them in with zeros, okay? If I'm missing the x squared, I fill it in with 0x squared. If I'm missing an x, I fill it in with 0x. So you have to have those placeholders to line up. So if I look at what I'm dividing into, 9x squared plus 6x plus 5, it is in order from highest exponent down to none, and there's nothing missing. So this is going to go underneath my division bar. Then I look at what I'm dividing by, 3x minus 2. The highest exponent there is 1, the lowest is none, and there's nothing missing. It's in order, so I put that on the outside. So now it's first into first. Do not worry about your second term for this first step. What would I have to multiply 3x by to get to 9x squared? Or what is 9x squared divided by 3x? 3x. So that goes at the top. Now I worry about what's on the outside because this 3x is going to get multiplied by both terms. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. With me so far? Now I change my signs on what I just multiplied, so it becomes a negative 9x squared and a positive 6x, and I add. If I've done this step before this correctly, the first two terms should cancel out, which they do, and then I get 6x plus 6x, which is 12x. Bring down the next term, which is a positive 5. Repeat the process. What do I multiply 3x by to get to 12x? What's
4.
Good? 12x divided by 3 is 4. Multiply that 4 times both terms. 4 times 3x is 12x. 4 times negative 2 is negative 8. Change your signs and add. 12x's cancel out like they're supposed to. What's left is 13. 13 is my remainder. 3x plus 4 is my quotient. So my answer gets written as 3x plus 4 plus 13 over 3x minus 2. Questions so far? We remember this from last year? Possibly not fondly, but at least we remember it. Synthetic, I'm a nerd, but I think synthetic is fun. This, not so much.
Remainder, and what would be 3x minus 2?
That's the divisor. So whatever's on the outside, that divisor is what you put under the remainder. All right.
It's like
Yeah.
13 is the...
Okay. We're going to do it again. This time, look at first my dividend, right? I have x to the third plus 3x minus 2. Are they in order? Yes. Are they missing terms? Also yes. We're missing the x squared. So I am going to add in a 0x squared. Then I look at what I'm dividing by. Are they in order? Yes. Am I missing a term? No. So I'm writing my dividend, 3x plus 0x squared plus 3x minus 2 divided by my divisor, x squared plus 5x minus 3. And then it's first into first again. So x3 divided by x squared, or what would I have to multiply x squared by to get to x to the third, would be x. I'm going to multiply it times all three things. X times x squared is x to the third. X times 5x is positive 5x squared. X times negative 3x is negative 3x. Change your signs. Minus, minus, plus. X to the third minus x to the third cancels. 0x squared minus 5x squared is a negative 5x squared. Positive 3x and positive 3x is positive 6x. Bring down the next term. Still with me? Repeat that process. What do I multiply x squared by to get to negative 5x squared?
Negative 5.
Good. So negative 5 gets multiplied times all three terms. Negative 5 times x squared, which is negative 5x squared. Negative 5 times positive 5x, negative 25x. Negative 5 times negative 3, positive 15. Change your signs and add. Negative 5x squared, positive 5x cancels out. 6x plus 25x becomes 31x. Negative 2 minus 15, negative 17. Now the exponent on the outside has become higher than the exponent on what I've got to divide into it, so I am done. That whole thing is my remainder. Yep.
How did you get the purple negative 5x squared?
I multiplied this times the x squared. So you're multiplying each term, and then change your sign. So now my quotient is what's up here, x minus 5. My remainder, so this is a plus, is 31x minus 17 goes over x squared plus 5x minus 3. Questions on that one? All right, the division algorithm is a fancy name for something you already know. If the remainder is 0, then we say the divisor divides evenly into the dividend, and the divisor and the quotient are factors. So if my number was 22, and I was dividing by 2, I would say 2 is a factor of 22 because it divides evenly into 22. There's no remainder, right? So it is the exact same with a polynomial. If I take something and divide it into the divisor, take the divisor, divide it into the dividend, and my remainder is 0, then I say what I divided by divides evenly into it, and whatever I'm dividing by is a factor. So just some terms like for vocab, right? It could ask you, is x minus 2 a factor of this polynomial? And if when you divide it gives you a 0, the answer is yes. And if it doesn't, the answer is no. So synthetic division starts exactly the same first step. We're going to arrange the polynomial in descending powers with a coefficient of 0 for any missing term. So you rearrange highest to lowest. If you're missing a term, you plug in a 0, x, whatever that is, okay? Same exact step as for number 1. Then, if the divisor is x minus c, you're going to take whatever c is, so the opposite sign goes on the outside of your synthetic division bar, and you write just the coefficients of the dividend on the right, which means there's no more variables when we do synthetic, okay? We bring down the first term, we multiply what's on the outside by that term and put it in the next column. We add it, we multiply what's on the outside by what's on the bottom, we put it in the next column, we add it, and so on and so forth until we get to the last number. When we go to write our answer, the last number is your remainder, and then you go in increasing degree from that point to the left, starting with the coefficient. Every time I do this, people are like, that's a lot of words. And then we start it, and you're like, oh, I remember this now. Okay? So let's just get right into the example. This, go ahead.
Did you skip a slide?
Did I? All right, so just to stress that synthetic can only be done, it can only be done if what you're dividing by is an x to the first. If that is x squared plus or minus anything, you cannot use synthetic division. It's also trickier to do it when there's a coefficient on the front. So if this was like 3x plus 2, it can be done, but you have to use a fraction on the outside of what we're about to do, which gets sloppy, okay? So it can be done with a coefficient on the front. I would not recommend it, but it is possible. So you cannot do it if it's x squared. And So for a question on your test that says use long division, it will not be one. You can also use synthetic. It will force you to use long division. Okay, I know with the choice I would go with synthetic too, but you need to know how to do both. All right, so let's start synthetic. I take the opposite of what follows x, which means I make the outside number -2. I'm going to draw a big long L. Some people go back the left way. I don't care how you draw your box. Draw your box however you want. I'm going to make sure my coefficients here are in order from highest down to none, not skipping any terms. I have x to the third. I am missing an x to the second, so I have to add in here a positive or negative. It doesn't matter because it's 0. X to the second. So I always make them positive, but it doesn't matter.
How do you change the sign?
Because this is taking the place of the change the sign and add step that we do with long division. By changing the sign on the outside, we don't have to do that step. So now I'm going to list my coefficients: 5, 0, 6, and 8. If it was a -8, it would have been a -8. So whatever the sign is, you keep it with it. Now step 1, bring down the 5. Multiply by what's on the outside. -2 times 5 is -10. Put it in the next column. Add them. 0, -10 is -10. Multiply what's on the outside times what's there. -2 times -10. Put it in the next column. 20. Add them. 26. Multiply what's on the outside by what's there. -2 times 26, -52. Add them, and I get -44. Does this look familiar? Yes, okay. Is this super fun? Yes, it is. Yeah. I would like to do like a timed thing where we get to do like, where you used to do like minute math multiplication. I feel like we could do synthetic division in there. We can make it an Olympic event. Speed. But I don't want you to go so fast you make a mistake, so I don't want to stress that. All right, so this last number is my remainder. Then as I move left, the next number stays without a variable because that's the constant. The one to the left of it gets an x to the first. The one to the left of that gets an x to the second, and it would continue to move up as I move to the left. The first exponent should always be 1 less than the exponent on the divisor, or the dividend, sorry. So 5x to the third was my dividend. My answer should be an x to the second, and it is. So my quotient is 5x squared minus 10x plus 26. And my remainder is -44. Instead of writing plus a -44 over x plus 2, we bring the negative from the front to in between these two. And my answer looks like that. So the negative comes off the top, or the remainder, and it goes in between, making it a subtraction. Questions? So again, only can be done if what you're dividing by is x to the first. If it's x to the second, it can't. You have to do long division. And you will have to do long division when we get to rational expressions, which is why I'm forcing you to learn both, okay? We use synthetic for a lot of things, so this is something that you definitely want to be able to do well, comfortably, without having to revert back to steps. You want to practice this so many times that it's like second nature and it's fast. You just have to be careful. All right, let's do it again. Divide using synthetic division. So again, now it's just written different format. The top is my dividend, the bottom is my divisor. What goes on the outside of my little L?
X minus, no wait, the +4.
Good. Change the sign so it's +4. Draw your big L. Look at my dividend. Is it in decreasing degree order? Yep. Am I missing any terms? Nope. So I write the coefficients. 3, -5, 7, -8. Bring down the 3. Multiply it by 4. Put it in the next column. Add it. multiply it by 4, put it in the next column, add it, multiply it by 4, put it in the next column, add it. Did I do that right? Yeah. Here's my remainder. The 35 stays as the constant. The 7 gets the x. The 3 gets the x squared. So my answer is 3x squared plus 7x plus 35 plus 132 over x minus 4. Questions on that one?
Negative if the 132 is negative?
Correct. Yep, you're welcome, Taylor. So the question was, the only way that this becomes negative if this was negative. Yes. All right.
So the last
Oh.
piece
Oh.
becomes
So in this case, you're going to get given an f of x equals, and it's going to be x to the third something. And you're going to get given one root. Given, x equals, let's say it's 2. I'm going to take the 2. I'm going to put it to the outside. I'm going to use synthetic division here by bringing these down. My answer is going to have a remainder of 0 because this is a factor. It told me it's a factor. If it doesn't have a remainder of 0, I did something wrong. And then I will take the quotient here, which would now be an x squared, and I will either factor it if it's factorable, or I could use the quadratic formula. One way or the other, I can get to my remaining roots.
So you wouldn't change the sign if it's x is equal to a number?
Correct. If it gives it to you like this, then 2 goes there. If it says x minus 2 is a factor, then you change the sign. So if the number follows x, you change the sign. If the number's by itself, you leave it alone. All right, so this says solve the equation x to the third minus 7x plus 6 equals 0, given that 2 is a 0. So 2 is the factor that's given to me. That goes on the outside of my synthetic division bar. Then I look at my dividend. Is it in decreasing degree order? Yes. Are all the terms represented? No. I'm missing a 0x squared. So I plug that in. Now list your coefficients. So 1, 0, negative 7, 6. Bring down the 1. Multiply it. Put it in the next column. Add it. Multiply it, put it in the next column, add it. Multiply it, put it in the next column, add it. If you don't get a 0 on this kind of question, you did something wrong, or I did a typo. Hopefully it's on you and not me. This is my remainder 0, which confirms that 2 is my factor. The negative 3 is my constant. The 2 gets the x, the 1 gets the x squared. So my quotient is x squared plus 2x minus 3. And if I want to solve this, I factor it. X plus 3, x minus 1, and my other two zeros are negative 3 and 1. So when it says solve, it means give all the zeros as the answer, which means my zeros are negative 3, 1, and the 2 I got from the beginning. You have to include that as one of your zeros. So it gave it to you, but you still have to include it in your answer. Questions on that one? So again, it's going to give you a 0. You are going to put that on the outside. You are going to use synthetic to decrease it a degree from cubic to now quadratic. And then quadratic is always solvable. most likely factorable, but if not factorable, you can use the quadratic equation.
So only when we're given a 0 is when we do the whole thing and then factor it after.
Correct. If it was just like an x squared, let's say it's an x squared and I give you a 0, then when you bring it to the outside, so if I took this, if I took this, right, if I took this one, x squared, which would be 1 to negative 3, and I took another one of these roots, like 1, put it on the outside, it decreases it a degree again, and then what's left is my last 0. So if by chance you get something like, let's say a standardized test, it gives you an x squared and it gives you one root, then you can actually do the same thing with it. You can decrease it a degree using synthetic, and the remaining root is going to be what's left from your quotient. All right, last example. So verify the given factors of f of x. Find the remaining factors. Use your results to write the complete factorization, and then list the real zeros of f. So we're going to do this piece by piece. The first thing says f of x equals 2x to the third plus x squared minus 5x plus 2x. And it actually gives me two factors. It gives me x plus 2 and x minus 1. The easiest thing to do is grab one of those and reduce this a degree. So if x plus 2 is a factor, then what is my 0?
-2.
Good, that goes on the outside. Look at my polynomial here. It's in order of decreasing degree. Every term has a number, so I just rewrite 2, 1, negative 5, 2. Bring down the 2.
Can't you just like FOIL
You sure can.
those two and get?
Yep.
Oh.
Yep.
So we're trying to find the other 0, right?
Correct. So you have options. This is just one, and then I'll walk through that method too, Matt. But yes, that is absolutely right. So I bring down the 2, I multiply it, put it in the next column, I add it, multiply it, put it in the next column, add it, multiply it, put it in the next column, add it, and there's my 0. Again, confirming what they already told me, which was that negative 2 is a factor. Now I have 2x squared minus 3x plus 1 as my reduced degree polynomial. From here, I have two choices. I could either factor it again, I could factor it from here, or they gave me another 0. So I can take my reduced polynomial, 2, negative 3, 1, and put my second 0 on the outside, which would be 1. Bring down the 2, 2, negative 1, 0, and I just reduced it a degree again, making it 2x minus 1. That is my last factor. So I verified by dividing into the using synthetic division and showing that it's 0. That's the verifying part. Find the remaining factor. I just found it. Use your results to write a complete factorization, means all three of these. So my complete factorization is x plus 2 times x minus 1 times 2x minus 1. That is my initial function completely factored. D says list all the real zeros. So I've got my negative 2 and my positive 1 from what I was originally given, and then set this equal to 0, and I get 2x equals 1 and x equals 1/2 as my last root. That is one method. I think it's the easiest method, so that's why I teach it first, but it is not the only method. Like Matt said, can I take these two and FOIL them out? I'd get x squared plus x minus 2, and then divide this by that. And the answer is absolutely. If you do that, x squared plus x minus 2, divided into 2x to the third plus x squared minus 5x plus 2, this would be 2x, multiply it times all three. Change my signs, cancels, -1. Change my signs, cancels, 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 and there's my last factor. So completely up to you how you choose to do this. Those are two different methods that you can use either one, but your end result should be the last remaining factor, the complete factorization, which is all of the parentheses, and the complete list of roots, which includes the ones they give you at the beginning, plus the one you found. Now, most likely, if I'm going to give you a question like this on your test, it's not, I'll give you one root. I'll give you one root, like kind of like the last one. You're going to reduce it a degree. You're going to take your quadratic, and you're going to either factor it or you're going to use the quadratic. And then you're still going to give me answers in multiple formats. You're going to give me the zeros. You're going to give me the complete factorization, okay? So make sure you know the terminology there. This, again, is the complete factorization. All the parentheses, including the one I originally give you. This is listing the zeros or the roots, because they're the same thing. And that is just the numbers. And you have to include the ones that are given to you. That's part of it. So when it says remaining, like A, obviously it's just the remaining one. But if it says complete factorization or all roots, you have to make sure you include what was given to you as part of the answer. Questions for me up to this point. So we're going to stop here because moving forward is your possible roots and then finding them and then reducing them, like all that stuff, the P's and Q's, if you remember that stuff from last year, okay, which is what we will continue after your test. But for right now, this is where we're at. Again, questions? Okay, hold please. I have to go into WebAssign and alter your assignment to where we are right now.